Hi, and welcome to section 1.3. Today we're going to focus on subtraction with whole numbers. Last time we did addition. This time we're going to do subtraction, which is, as we're going to find out, it's kind of like the opposite of addition. And so we've got some vocab that we're going to cover. We're going to subtract whole numbers when you don't need to borrow. So that's kind of your regular subtraction. We're going to subtract when we do need to borrow. And we're going to we're going to solve subtraction equations. All right. So the first thing we need to define is what subtraction produces. And it produces a result called the difference. And so when we see subtraction, we can label it a couple of different ways. We can say things like, in this case, A minus B, or we can say B subtracted from A. But really, in mathematical terms, what we like to think of it as is the difference of A and B. So it's the difference of two numbers, A and B. And whatever difference we get, when we do the subtraction, that result is called the difference. Just like the result of addition is called a sum, the result of subtraction is called a difference. And there's some reasons why, and we'll think about those in just a second. And so in English words, you could say something like the difference of 9 and 1. And so the difference lets you know that you're going to be subtracting, and then the order tells you the order in which they come. So if the 9 comes first, then it goes first, just like it comes first here in the sentence, so it goes first in the symbols. If the 1 comes first, then it goes first. The difference of x and y is x minus y. 3 subtracted from 8. So it lets you know the 3 is coming away from the 8. So when you go away from something, you actually start at that thing. You start at the 8 and you take away from it. And so in this case, the order is reversed whenever you see subtracted from, because from lets you know, I'm starting from the last place I mentioned, right? So if I say I'm going away from here, well, then I started here and I'm leaving. And that's what this 8 minus 3 represents. 2 subtracted from t, a number t. And now this one is actually an equation. The difference of 9 and 3, so we subtract 9 and 3 in that order, is 6. And that's a true statement. When we want to subtract, we really like to do it a lot like we did addition in the last section. So if we have something like 376 minus 241, that's 376 minus 241. It's kind of hard to deal with those numbers just in our head. So we want to write them down. And when we write them down horizontally, it's hard to keep track of the place values. So I like to write them vertically, stacked on top of one another, the operator off to the side like that. And this allows me to line up the place values and do the arithmetic. So I've got 6 and 1. They're both in the ones place, so I can just subtract them. 6 minus 1 is 5. 7 minus 4 is 3. 3 minus 2 is 1. And there we are. I have 135. That's the difference of 376 and 241. It's really important to keep my place values lined up. And with money, it's a really clear example here. If I had, say, $376 and I had it in hundreds, hundreds, tens, and ones, and then I was going to spend some of that money, right? Then I'm taking it away, and when I spend that money, I'm taking it away from the same place values. And so when I line up my columns, that's what I'm showing, is that I'm lining up my ones, my tens, and my hundreds so that I can do the math. Now, sometimes I'm subtracting and the the digits in the first number are not always larger than the second number. So in this case, I'm going to take my find the difference of 549 and 187 means subtract those two numbers. But of course, it's difficult to subtract horizontally, so I'm going to stack them so that I can line up their place values. And when I do this, I can go ahead and subtract 9 minus 7 is 2, but 4 minus 8 can't be done. Now, in the real world, what would I do? I would take one of my $100 bills, if this were money, say, and I had $549, I'd take one of my $100 bills and I would break it. What does that mean? That is borrowing. That means I'm going to take one of my larger denominations and I'm going to split it up into a bunch of my smaller denominations so that and essentially I'm borrowing a 10 is what I'm doing. I'm borrowing a 10 and splitting it up so that I can do the subtraction. So instead of thinking of it as 549, I'm sort of thinking of it as 500, right? Thinking of the 500 as 400 and 100 that is actually in 10 tens. That way I can use it in the next place value over. So I'll have 10 tens. So instead of 500, I'm going to break one of my hundreds. So I have 4 hundreds left. That's this piece. And I'm going to take the other 100 and I'm going to split it up into 10 tens. So 10 tens means that instead of 4 tens here, I have 14 tens. Now, 4 minus 8 can't be done, but 14 minus 8 can be done. In other words, 14 is like 140. So I borrowed that 100, now I have 140. Oh, now I can take away 8, right? So 14 minus 8, that's 6. 4 minus 1, that's 3. And that's why those addition facts are actually so handy from the last section, because they can help us do subtraction in this section. Now, we can solve equations simply by inspecting them when they're simple enough and the numbers are small enough and manageable enough, and we can kind of do a lot of the work in our minds. And so let's go through each one of these. So A is n minus 3 equals 7. A number, take away 3 leaves 7. So what number, when you subtract 3, gives 7 left? Well, that number has to be 10, right? Because 10 minus 3 equals 7. So the number that makes this true in place of the variable, the letter that we're using to represent some number, that has to make it a true statement. So in this case, the n is a 10. Let's have a look at B. N minus 4 equals 9. Some number, when you take away 4, gives you 9 still. So that means it has to be bigger than 9, because when we take away 4, we still have 9. So really it's 4 more than 9 is kind of a way to think about it. So that number has to be 13, because 13 minus 4 leaves 9. And C, 12 minus a number equals 5. Let's try that again. And I think I might have given it away because my brain was already working. 12 minus a number is 5. So 12 minus what number is 5? 12 minus 7 is 5. Let's have a look at D. 7 equals 18 minus a number. 18 minus, 18 minus 10 would be 8. So 18 minus 11 would leave 7. So 7 equals 18 minus 11. And that's how we do these. That's how we solve these by inspection. So let's review some of the key concepts in this section before we go on. So we'll look at A. Which sentence below describes the problem in example 1? So the difference of 241 and 376 is 135. So let's see. So either A, the difference of 241 and 376 is 135, or B, the difference of 376 and 241 is 135. Now, on some level, it's kind of straightforward because if you have, let's say this is money, if you have $241 in example A here, and you try to spend $376, what happens? Well, you don't actually have enough money. So this can't be a representation of a whole number, right? Because whole numbers are positive. So this is a positive amount of money. So if I have 376 and I try to spend 241, that is something I can do. So B. We'll look at part B. Write a subtraction problem using the number 234 that involves borrowing from the tens column to the ones column. Okay, so that could be something like 234 minus 15, right? It doesn't have to be a lot of borrowing, but 4 minus 5 can't be done, so I have to borrow from the 3, make it a 2, and give one of them to the next place value over. So instead of 4, we're looking at 14. 14 minus 5, that's 9. That can be done. 2 minus 1 is 1, and the 2 comes down. So there's my example for B. I hope you come up with a different one. For C, write a subtraction problem using the number 234 in which the answer is 111. So, in other words, 234 minus some number equals 111. And of course, you could actually do some number n minus 234 gives 111 as well. That would be a subtraction problem using the number 234 in which the answer is 111. So that would be perfectly fine. But this one seems like a little bit more fun to me for some reason. So 234, when I take away what number would leave me, what number would leave me 111? So let's see, 4 take away 3 would leave me 1, 3 take away 2, and 2 take away 1. Ah, cool. Okay, so 234 take away 123. 234 take away 123, excuse me, would leave 111. Okay, perfect. So I've got one for C. Now, part D, last part. Describe how you would subtract the number 56 from the number 93. How are you going to subtract here? So what I would say is, well, in order to subtract in the ones column, I'll have to borrow from the tens, and so I'll turn 9 into 8 and borrow one of those tens and give it to the 3 to make it 13. And that will allow me to subtract. So 13 minus 6, 7. 8 minus 5 is 3. And so my result is 37. And of course, what they were asking for was to describe it. So I might say what I just said, but in words. So borrow a 10 from 90. Let's see. Maybe say to subtract the ones. So that's the real challenge there, is having to borrow to subtract the ones. All right, so that's it for this section, and we'll see you in 1.4 for the next one.